Good evening, everyone. Welcome back again. We are in the third lecture of engineering mathematics, important question and answer. And we were actually was doing the rank of the matrix. In the last lecture, I have explained how to find the rank of the matrix. Okay, but that matrix were a square matrix. That is, the number of rows and the number of columns are equal. Okay, today we are actually going to explain how to find out the rank of the non-square matrix. Okay, finding the rank of the square matrix is quite easy. Non-square matrix is also quite easy, but you need to remember something. You need to remember some tricks there. Okay, actually, in different books, you can find different methods to find out the rank of the matrix. Methods are actually there are means one method is very simple, which is row reduced form, row reduced echelon form or echelon form. Okay, but that form, that is that row reduced form, is actually you can differ from different books. Okay, I apply some a very useful method. Okay, and if you use this method, then you can also find the rank of the matrix. And in case of the solution of system of linear equations, you can also easily find out what is the solution of the system in minimum time. So let's start with the rank of a non-square matrix. Okay, I just first just I remind you how you can find out the rank of a square matrix. Already I have explained it in the last lecture, but I am giving you another example of that. Okay, and this example, now this example, what I am going to give you, it is a 3 cross 3 matrix, and the matrix is like this: 1 1 0 0 1 minus 1 2 1 4. Okay, so it's a square matrix, 3 cross 3. You can see here 3 cross 3 square matrix. So how to find out the rank of this matrix? Basically, when the matrix is a square matrix, 3 cross 3, okay, better to form this matrix like this. You can see just below the diagonal elements. You can see these are the diagonal elements. 1, this 1 and 4. These three are the diagonal elements. And what I suggest, just below the diagonal elements, all elements, what are the below elements? 0, 2 and minus 1. Make these three elements as 0 with respect to the previous rows. That is, this is already 0, you can see, so no need to make it. But this is 2, so you can make this 2 0 with respect to the first row. Okay, similarly, look at this element. You need to make it 0 also, because this is 1. You have to make it 0, okay, with respect to the second row. Okay, with respect to the second row. Okay, so remember that these two elements, you have to make this element and this element 0 element with respect to the first row, that is row 1, and this element with respect to the second row, that is row 2. Just to remember this one. Okay, so let's find out the rank of the matrix according to what the methodology what I suggest. Okay, so now you can see this element. So what I suggested in the last class, that make the diagonal elements, that is the first, if the 3 cross 3 matrix is there, that is the 3 cross 3 square matrix, the first and second diagonal elements, make them 1. You can see already these two elements are 1, so no need to make them 1, already it is 1. Okay, now we need to make some row operations. So you can see this element is already 0, no need to make. This element is 2, so we need to make this element 0 with respect to the first row. Always remember the element which is going to be changed, that is, you can see this is going to be changed. So this element belongs to which row? This is row 3. Okay, so the row which is actually going to be changed, we will write the row in the first position, R3. Okay, remember that actually we are going to change this 2 as 0, but accordingly, since this 2 is situated in row 3, so this 1 and this 4, these two elements will also be changed, because we cannot make only the one element of a only a single element of this row. We cannot change them. If I want to change a single element of this row, then all other elements of this row will also be changed. Okay, so the first, this 2 is situated in row 3, so first we will write R3. Okay, that is the row which is going to be changed. We will first put that row. Now with respect to which we are going to change? With respect to the first row we are going to change. So we will write here. Now look at this, this is 1 and this is 2, so simply we can make minus 2 into R1. Okay, minus 2 into R1. Now how can this will work? R1. Okay, now look at this. I am each and every step I will explain with the um, calculation also. Now what is the first element? Row 3, so it means that row 3 minus 2 into row 1. Okay, now what is the first element of row 3? You can see 2 is the first element of row 3. So 2 minus 2 into what is the first element of row 1? 1. This. So you can see this becomes 0. 2 minus 2. Okay, now since the operation is entirely on row 3, okay, what is the second element of row 3? This is 1. Okay, so we will also change it with the first row. So 1 minus 2 into what is the second element of row 1? This is also 1. This is equal to minus 1. Okay, now what is the third element? So you can see what is the third element? 4 is the third element of R3. So 4 minus 2 into what is the third element row 1? 0. 0. So it becomes 4. Okay, now we are going to rewrite the matrix again, since only row 3 is changed. Okay, so row 1 and row 2 will be intact. So 1 1 0 0 1 minus 1, and now it is what is the first element? It becomes 0. Second element is minus 1. Third element 4. Okay, now second operation. Now you can see that this diagonal element is already 1, so no need to change. Now what we need to change? This element as 0 with respect to the second row, that is row 2. So what is the operation we can do here, or we can form? So operations here will be what row we are going to change, since it is also row 3. Okay, so this element is actually third row element, so we will put row 3 first. Okay, but you can see that second element, that is in the second row, you can see this is 1 and this is minus 1. So what we can do? Simply we will add 1 into row 2. That's all. Okay, so this element will become 0 now. So how it is possible? Now we will operate it. Now row 3, R3 plus 1 into R2. So you can see what is the first element of row 3? 0 plus 1 into what is the first element of row 1? This is also 0. 0. So it becomes 0. Now second, what is the second element of row 3? Minus 1 plus 1 into what is the second element of row 2? 1. So this is 0 again. Now what is the third element of row 3? 4 plus 1 into what is the third element of row 2? Minus 1. So what happens? It becomes 3. Okay. So now row 1, since row 1 and row 2 is not changing because only row 3 is changing. Okay. So 1 1 0 0 1 minus 1 0, where the first element is 0, second element is also 0, third element is 3. Okay. Now look, you can see below the diagonal elements, all these three elements, this one and this one becomes 0 element. Okay, so after that we will not go further. Yes, in some books you can also see there are some other operations can also be done. Okay, in some other books you can see this element also they make it 0. Okay, this element also 0. Okay, and this element also 0. That operation you can do also, but that's not my target because I want to solve the problem in minimum in shortest time. Okay, so after in a 3 cross 3, if the matrix is a square matrix, then only up to if the below the diagonal elements, just below the diagonal elements, these three elements are 0 0 0 and 0, then we will stop our operation there. Okay, now you need to count, this is the last operation, this is the last matrix. Now you need to count the non-zero rows. How many non-zero rows are there? You can see first row. I already told you 0 row means all elements of the row must be 0. Is there any row like this? All elements of the row are 0? No. First row 1 1 0. Second row 0 1 minus 1. Third row 0 0 3. So no row is there where all elements are 0. Okay. So this particular matrix has 3 non-zero rows. It means that this implies the rank of the matrix is equal to 3. I think it is clear to you now. I've given you two examples, previous day one example, and today also I'm giving you another example of this. Okay, now I'm going to share you how to find out the rank of a non-square matrix. Okay, so let's start with an example. Okay, I am extending the previous example. Or better to give you a okay, so solve more numericals. Okay, so okay, numericals. If you want me to solve more numericals, then it will be time consuming. But let me first start with the non-square matrix rank. Then I will give more numericals for square matrix and non-square matrix also. Okay, okay. Let's start with the non-square matrix now. Let us find this matrix. This is quite a large matrix. 1 2 minus 1 10 -1, 1, 2, so this is the matrix. Okay, here also we will apply the same method. That is, first we let me now look at this. Here, what are the diagonal elements? We cannot actually find the diagonal elements because here the matrix is non-square. So diagonals, if you see the diagonals, we can only find it in a square matrix there. All diagonal, because it is a number of rows and number of columns are equal. But here, what can we see? Here we can use that leading elements. Look at this: the first here and the second here. Okay, basically, if the matrix is like this, you may use this element and this element as one. Okay, that is, you have to make this one and this one as one, and this one, this, and this. These three elements make them zero, just according to the previous method. Same methodology you can apply. Yes, after that, if possible, that is, if we see there is any chance to make this or this element is also zero, then we can move to the further operation, if it is possible then. Otherwise, the same method according to the previous, that is, you can see the previous one, the diagonal, that is the first, sorry, that is the this element, the just below the diagonal elements we made them zero. Exactly same thing, that is same method we will apply here also. Okay, so let us start. Okay, so let's start with the same method. What is the first element here? Is it 1? Yes, this is 1, so no need to make it 1 now. So what we have to do, we have to make just below, that is this element and this element, as 0 with respect to the first row, that is row 1. Now what is the operation here we can do? So you can see that second element, this is -1. The first element, now we need to make this element as 0 element, and this element is situated in which row? Row 2. So we are going to make change in row 2. So we will first write down row 2 here, R2. Okay, now this element we are going to make it 0. So what will be the operation with respect to this? So this is minus, this is plus. So simply we will add it, plus 1 into row 1, or -1 into row 1. Let me 1 into row 1. Okay, so R2 plus R1. Simply we add these two, R2 plus R1. You can see this element becomes 0. -1 plus 1. This element, the second element, it becomes 0. Okay, now how can you make this element, the third element, that is third row, first column element, 0 with respect to the row 1? Since we are going to make change the third row, we will write down the row 3 first, and row 1, this element is 1. So what we will do, -2 into, that is the third element, 2 into R1. Okay, now first row is not going to be changed, so 1, 2, -1, 10. Okay, second row, already this will be 0 and 0, because according to that we have made these operations. Okay, now what are these other elements of row 2? So in row 2 operations, you can see R2 plus R1. So simply we need to add the elements of row 2 and row 2, or row 1, and nothing else. So what is the second element of row 2? It is 1. What is the second element of row 1? It is 2. So 2 plus 1, 3. Okay, what is the third element in row 2? 2. third element of row 1 minus 1. So 2 minus 1, 2 minus 1, 1, and 2 and this 10. So 2 plus 10, 12. Now come to the third row. What is the second element of third row? 1. So 1 minus 2 into, look at this operation. Okay, minus 2 into R1, that is row 1. What is the second element of row 1? 2. So 1 minus 2 into 0, it is minus 3. Okay, now come to this element. Now what is the third element of row 3? 3 minus, look at this operation, 2 into, what is the third element of row 1? Minus 1. So 2 into minus 1. So what is it? What is it? Minus 1. It is 3. Sorry, 5. Sorry, something. I think there is a mistake in the, it is actually minus 3. Sorry, it is minus 3 actually. It's my mistake. By mistake I have taken, it is minus 3. Okay, and the 2 1 minus 3 2. Yes, now it is. So it is 2 and minus 3 minus 20. So minus 3, okay, plus 2, it is minus 1. What is the last element of row 3? 2. So 2 minus 2 into, what is the last element of row 1? 10. 10. Okay, so what is this? Minus, it is 20, so minus 18. So this becomes, now you can see these two elements is actually become 0. Now what is our next target? Okay, look at the second diagonal here. This is 3. So first we make this element as 1. And how can I do this? Look, this 3 is situated in which row? Second row. So simply we can do this R2 second row divided by 3. Okay, by doing this, first and third row will be intact. 1 2 minus 1 10. Second row it is 0 1 1/3 and 12 by 3, so it is 4. Third row will also be intact. 0 minus 3 minus 1 and minus 18. Okay, so this becomes the latest matrix. Now what should we do? So let me erase these operations. Our next operation. Now look at this. Now this becomes 1. Now what should we do here? This element will be 0. And can you tell me how to do this? Which operation is needed here to make this element is 0 with respect to row 2? With respect to row 2. So we are going to change row 3 with respect to row 2, and we are actually making this element as 0 with respect to this. So what will be the operation here? The third row is going to be changed. So first we will write row 3. Now second, this element is 1. So simply we will do 3 plus 3 into R2, row 2. So this is minus 3 and this is plus 1. So that is why we have used plus sign here. Okay, so 3 into 1. So simply after doing this operation, so R3 plus 3 into this, so what will happen here? Now you can see first row, we are not changing the first row, so first row will be intact, 1 2 minus 1 10. Second row, 0 1 1 by 3 4 will also be intact. Okay, and what will be the third row? Now third row, this is already 0 because this is 0. The third row operation is R3 plus 3 into R2. So what is the first element of third row? 0 plus, so 0 plus 3 into R2, that is first element of R2, it is 0. So 3 into 0, this is 0. That is, this is 0. Second element. What is the second element of R3? Minus 3. So minus 3 plus 3 into, what is the second element of R2? 1. This is also 0. This was our target actually. Okay, now come to the third element. What is the third element of row 3? Minus 1. So minus 1 plus 3 into, what is the third element of row 2? 1 by 3. Okay, it will be nullified. So this becomes also 0. This is also 0. Now come to the fourth element. It is minus 18. Okay, so fourth element, that is the last element of row 3, minus 18. Okay, and this element, what is plus 3 cross into, what is the last element of row 2? 4. So minus 18 plus 12, minus 6. So this is the last. Now we can see that this element, is there any possibility that this element will be 0 with respect to the previous one? No. If I want to make change of this element with respect to this, okay, as 0, then this element will also be changed. Okay, so we can't do this. So this is our last operation here. Okay, so accordingly, you can see this is the last operation, exactly same way what we have done in 3 cross 3. This is the 3 cross 3 matrix. Just we have given the example. Okay, exactly in the same way we will do the same thing here. Okay, if the fourth element is 0, that is, it becomes 0, automatically it will be 0. After doing any of the operations, automatically it will be 0. Otherwise, just this is the last matrix. Sorry, this is the last matrix. Okay, and what is the rank of this matrix? Non-zero rows. First row is non-zero. First row is non-zero. Second row, this is also non-zero. Third row, this is also non-zero because minus 6 is there. 0 row means all the elements of the row must be 0. Okay, so 3 non-zero rows are there. So it means the rank here is also equal to 3. Okay, so same operations we will do here also. Now let me check, there are other examples. So now I am giving you some other examples. Okay, and I want you to solve it. I will give you some time to solve, and please write down the chat box in YouTube chat box. Okay, and the previous day's lecture you can also, if somebody is new to this channel, the previous day's lecture, that is the rank of the matrix, and the introductory lecture of engineering mathematics, all these lectures you can find in our YouTube channel, InnovaWorld, and the link is on the description box. In right now you can also find it. Okay, now I'm giving you one example of a non-square matrix, and I will give you some time to solve it. Please solve it and write down in the chat box that what will be the rank for this matrix. Okay, Okay, the matrix is like this. It's too much easy. 1 2 minus 1 10, minus 1 1 2 2 2 1 minus 3 8. Okay, so you need to find the rank of this matrix. I'm giving you some time. I think 2 to 3 minutes are enough. Okay, I can see only one student already solved it. Rank is 2, he's saying. Okay, now let me explain the example here. Okay, how to find the rank here. So you need to check that what is the first element, first row, first column element. Is it 1? Yes, this is 1. So no need to change anything. Now what we need to do, the second row first element and the third row first element, second row first element and the third row first element has to be 0 with respect to the first row. Okay, so what will be the operation here? Second row is minus 1, second row first element is minus 1, first row first element is 1. So how can we make second row first element as 0? Simply R2 plus R1. R2 is minus 1, R1 is 1. We are going to make change in R2. So R2 will be in the first position, R2. First row it is 1 only, so 1 minus 1 plus 1. It becomes 0. So R2 plus R1. That's all. Now what is the third element? Sorry, first element of the third row, it is 2. And the first row, first element is 1. So what should we do here? R3 minus 2 into R1 simply. Okay, now the first row will not be changed, so 1 2 minus 1 10. Now come to the second row. This is already 0 because according to the operation. Now what is the second element in the second row? R2 plus 1, so 2 plus 1 it is 3. Okay, 2 minus 1 it is 1. Okay, 10 plus 2 it is 12. Now third one, R3 minus 2 into R1, so this becomes 0. So R3 minus 3 into R1, R3 second element of R3 is 1 minus 3 into second element of R1 is 2, so it becomes 3 into 2 it is 6, so 1 minus 6, this is I think something 1 2 minus 1 10 2 2 1 8. So R3, sorry, I have done something wrong here. Yes, this is minus 3, so R3 minus 3, third element, sorry, it is 1, and this is 1 minus 2 into R1, it is 2, sorry, it is 4, so it becomes 1 minus 4 minus 3. Okay, similarly the third element, it is minus 3 minus 2 into R1 minus 1. Okay, so minus 3 plus 2, so it is minus 1. The last element 8, this is 8 minus 2 into this is 10, so 20, so 28 it will be minus 12. Okay, so this is the second matrix. Now what about the third matrix? Now let me find out here. So what will be the third operation? Now you can see this element and this element, these two elements are 0 now. Now this element, we need to make it 1. Okay, so here you can see if you just add these two rows, row 2 and row 3, just add it. That is R3 plus R2. You are doing this operation only. You can see all elements of the third row will be 0 here. 3 minus 3, 1 minus 1, minus 12, 12. Okay, still you can do directly R3 plus R2 here. Automatically all the elements of the row 3 will be 0 here, because actually our target is to make this element 0. Okay, so this element will automatically be 0 if we add, that is simply we will do this operation R3 plus R2. Okay, but still since we are going according to the rules, so you can see this element is 3, so we can change it 1. So this element, the second diagonal, how can we make it 1? It is R2 divided by 3. So R2 divided by 3, the first 1 2 minus 1 10, second it is 0 1 1/3. Okay, and this is 4, that one 0 minus 3 minus 1 minus 12. Okay, now what is the operation? We need to make change, this becomes 0 with respect to this element. Okay, now what is this element? Minus 3 is on row 3, so we will first write row 3, and this is 1 plus, sorry, yes, because this is minus 3, so we will put it here plus 3 into row 2. So 1 2 minus 1 10, 0 1 1 by 3 4 0. Now this one, it will also be 0. Now minus 1. Now look at this operation, R3 plus 3 into R2. So what is the third element of R3? Minus 1. So minus 1 plus 3 into R2. So what is the third element of R2? 1 by 3. You can see 1 minus 1, 3, 3, it will be 0. This becomes 0. Now what is this one? R3 plus 3 into R2. So what is the last element of R3? Minus 12 plus 3 into, what is the last element of R2? 4. This is also 0. So you can see it is 0. Now can you tell me what is the rank of this matrix? Okay, you can see how many non-zero rows. This row is non-zero, this row is non-zero, but the third row, this is a 0 row, because all elements of the third row is 0 here. So what is the rank of the matrix? Rank here is equal to 2. Okay, so both square matrix and non-square matrix, okay, all matrices, now I think it is clear to you. Okay, so it is actually rank 2, not rank 3. Okay, so rank is 2 here. Okay, so why we are doing so? This is the end of rank of matrix. I also give you the a suggestion, that is, do practice, because rank of the matrix is very important for all competitive examinations, also your semester examinations also. Okay, and there will be at least you will be having the questions in engineering mathematics. Find the rank of the matrix. That may be a square matrix, maybe non-square matrix. Yes, basically in semester exam you'll be getting square matrix. Okay, but in gate examinations or other kinds of competitive examinations, you can have non-square matrix also. Okay, and there you can also have the non-square matrix where the number of row is more and number of column is less. That is also possible. Okay, now we are coming to why we have done this rank of the matrix. What is the necessity of it? Actually, rank of the matrix is important to find out the solution of system of linear equations. Okay, the formation of system of linear equations, I already have given you the example in the last class. Okay, that is a supermarket example. Three persons, they are going to the supermarket to purchase the sugar and the rice, and we need to find out what is the unit price of the sugar and the rice based on their payment. Okay, the three persons have made payment of different types of different means payments they have made in the supermarket, and they have also purchased different amount or different quantity of rice and sugar. So according to that, we have made a model, mathematical model, that is a system of linear equations. Okay, and we also have told you that we need to solve that equation, and if we solve this equation, we can find what is the actual price of rice and actual price of the sugar. Okay, so let us, sorry, let us add another slide here. Okay, so now we are going to give you an example of how to solve the system of linear equations. Okay, so system of linear equations, actually I told you that the previous day we have already solved, at least already have given you the example to form the system of linear equations. So I am giving you direct example of this. The example is like this: x1 plus x2 is equal to 4, x2 is equal to 1, 2x1 plus x2 plus 4x3 is equal to 7. Okay, this is a solution of system of linear equations. Sorry, model. Now we need to know something here. How many variables? Every system of linear equations has some variables. Okay, you can see here. These are the variables. How many variables are there? X1, X2, and X3. Okay, you can see though in the first equation, this is equation 1, this is equation 2, and this is equation 3. Though in the first equation you can see there is x3 is missing. In the second equation you can also see x1 is missing. Actually they are not missing, their coefficient is actually 0. So we can rewrite the first equation as 1 into x1 plus 1 into x2 plus 0 into x3 is equal to 4. We can rewrite the second equation as 0 into x1 since x1 is missing. So of course the coefficient of x1 is 0 plus now x2 1 into x2 and minus 1 into x3 is equal to 1. We can rewrite the third one. Third one, no need to rewrite it because all variables are present there. So 2 into x1 plus 1 into x2 plus 4 into x3 is equal to 7. Okay, so this is the system. Now every system of linear equations can be represented as a matrix form. How? You can see what is the first coefficient here? 1. Second coefficient 1, third one 0. Now this is 0, 1, minus 1, 2, 1, 4. Okay, so we can write this system as the matrix 1, 1, 0. Okay, 1, 1, 0, 0, 1, minus 1, these two, these three, and 2, 1, 4. Okay, after that we will form a column matrix x1, x2, x3, and on the right hand side another column matrix 4, 1, 7. Okay, so this system of linear equations can be written in this form, in matrix form. So how you can go back to the previous equation? You can simply multiply. This is a 3 cross 3 matrix. This is a column matrix x1, x2, x3. Simply multiply 1 into x1, 1 into plus 1 into x2 plus 0 into x3. So 1 into x1 plus 1 into x2 plus 0 into x3. You can see here. Second row you can see 0, 0 into x1, 1 into x2 plus minus 1 into x3. 1 into 0 into x1 plus 1 into x2 minus 1 into x3. This should be equal to 1. And third one 2 into x1, 1 into x2, 4 into x3. 2 into x1 plus 1 into x2 plus 4 into x3 must be equal to 7. So this is how this system of equation can be written in matrix form. Okay, this matrix is called coefficient matrix. Okay, generally represented as x. This matrix is called a vector matrix. Okay, that is x1, x2, x3. Actually this is a in after solving this equation we will be getting three values: the value of x1, the value of x2, and the value of x3. Yes, if they exist. Not all system of equations has the solution. If the solution exists, then we will be getting some value of x1, some value of x2, and the value of x3. So these x1, x2, and the value of x3 together will represent one point. Okay, that is why we what is x? X is a vector which represents this column matrix x1, x2, and x3. What is b? B is another column matrix, this one, 4 1 7. Okay, now we need the rank of the matrix to find the solution of this equation, system of equation. Okay, so let us I will first I will solve this equation first. I'm not going to today I'm not going to give you much more example of this, because I will give all examples of system of linear equation. There are a lot of examples I have to show you, because this is too much important for any kind of competitive examination. Okay, system of equations, whether they have the solution or not, okay, you need to check it. And from that particular topic you'll be getting many MCQ questions, not only in competitive examinations but also in your semester exam also. System of linear equations also is too much important, equally important for any project work. Okay, so let us first write down the coefficient matrix here. Now I'm going to solve it. Solution: first find out the coefficient matrix. Okay, so what is the coefficient matrix? 1 1 0 0 1 minus 1 2 1 4. This is the coefficient matrix. Then we will write down the B matrix, that is the right hand side, 4 1 7. Okay, after that we will find another matrix which is called augmented matrix. Okay, and which is the matrix of A B together. Okay, it means that the augmented matrix, generally it is represented as A bar. Just combine these two matrices A and B. So 1 1 0 0 1 minus 1 2 1 4, and the right hand side, that is B matrix, is 4 1 7. Okay, just have given some gap in between them, because just to understand, otherwise you can easily combine this matrix. Okay, now we need to find out the rank of this matrix. Okay, so better to uh, give a partition here. I'm given a partition. Okay, so how to find out the rank? So is this 1? This is already 1. This is already 0. Just we need to make the third element this as 0 with respect to the first element, this. So what is the operation here? We will do the operation as R3 minus 2 into R1. Very simple. R3 minus 2 into R1. So this becomes 1 1 0 4 0 1 minus 1 1 0, and it becomes minus 1 4 1 is minus 1 4 minus 1. Okay, I'm not going to show you the operations because already I have shown you all the operations here. Okay, now what we do, we will make, this is already 1, we will make this element as 0. So it is R3, okay, plus R2. Okay, simply R3 plus R2. So this is 1 1 0 4 0 1 minus 1 1, and it is 0. R3 plus R2, it is 0, and it is 3. Okay, and it is also 0. And that's all. I think no need to do some operations, the operations here. Yes. Okay. Now here you can see that entire matrix is the augmented matrix A bar. But this matrix is A, okay, that is equivalent to A matrix, and this matrix is the equivalent matrix of B, right? So we need to check first what is the rank of A bar. Can you tell me what is the rank of A bar? Rank of A bar. Non-zero rows. You can see what is the wrong non-zero row here? 1, 2, 3. All rows are non-zero. 3. Now what is the rank of A? Only A. What is the rank of A? Now rank of A will be denoted by only this matrix. How many non-zero rows are there? First, second, third. All rows are non-zero rows. This is also 3. Remember that this system, that is this system of equation, the given system of equation has a solution if these two ranks, that is rank of the augmented matrix and rank of the coefficient matrix, are equal. If they are equal, then and only then we can say this system of equations is consistent. And what do you mean by consistent? Consistent means it has a solution. Okay, it has a solution. Yes, that solution may be infinite, may be unique. Okay, now how can you find the solution? Look at the last matrix. Okay, I'm highlighting the last matrix here. This is the last matrix. Okay, look at the last matrix very carefully. Okay, look at the coefficient matrix. The coefficient matrix, first element is 1, first row first element is 1, first row second element is 1, third element is 0. So can we write it as 1 into x1 plus 1 into x2 plus 0 into x3, okay, is equal to 4, that is here 4. And from the second row, can we write it 0 into x1 plus 1 into x2 minus 1 into x3 is equal to 1. And can we write from the third row 0 into x1 plus 0 into x2 plus 3 into x3 is equal to 0. Now look at this. From the third equation, what we are getting? This is 0, this is 0. 3 into x3 is equal to 0. So it means x3 equal to 0. Now come to the second equation. We already have, look at this, x1 is already 0 coefficient, but it has x2 minus x3 is equal to 1. x3 is already 0. So put here x3 equal to 0. We are getting here, from here, 1 into x3, x2, sorry, 1 into x2 minus 1 into x3. x3 is already 0, so 1 into 0 is equal to 1. So we are getting x2 is equal to, what is the value of x2? 1. Look, already x3 value and x2 value we have got. Now come to the first equation. Okay, we already have x3 values, we already have x2 value. Put it in the first equation. So from the first equation, what we are getting? 1 into x1 plus 1 into x2. What is the value of x2? 1. 1 into 1 plus 0 into x3. What is the value of x3? 0. 0 into 0 is equal to 4. So what is the value of x1 here? x1 equal to 4 minus 1. This is equal to 3. So this implies x1 is equal to 3. So we have the solution now: x1 3, x2 1, x3 0. Okay, and this solution is unique. You can see 1 is 3 1 0. It is 3, x1 value is 3, x2 value is 1 and 0. This solution is unique. This is the final solution. Okay, so this is how we can get different solutions here. That is a solution of system of linear equations. Yes, I can share you for practice. Based book, actually there are different books available for engineering mathematics in the market, and almost all books are good. I cannot say that which book is best or something. Okay, but yes, some practice questions are there also. In practice questions, some PPTs are also available in the internet, or some notes are also available. So I will share you that notes for that. Okay. Yes, I will repeat the same thing, but in the next class, not today. Okay, because I have explained too many examples today. Okay, now it will be going just out of here, out of the mind. So that is why just to practice the rank of the matrix, non-square matrix and square matrix both. System of linear equations. Try to solve, at least try to find out the rank of the augmented matrix. Okay, and now let me explain now again. I already told you in the last class also. I have shown you the softwares, MATLAB software, how to solve the rank of the matrix. Okay, how to find out the matrix operations, different kinds of matrix operations by using MATLAB. So today also I will be giving you the matrix, that is how to represent the system of linear equation in MATLAB and how to solve it. Okay, so let us first. Let me go. Okay, now come to the equation now. So in the last class we have done this matrix operations. Okay, I am clearing this one. Okay, so matrix, actually we can easily uh, see a matrix in MATLAB. Suppose the equation, I'm giving you the equations, you can easily find it out. Number of variables, suppose 3. Number of variables are 3, and number of equations are also 3. Okay, so okay, let me first give you just a matrix, that is the number of equations, that is a matrix. Coefficient matrix A is given as this: 2 1 1. Second row is minus 1 1 minus 1 minus 1 1 minus 1, and the third row is 1 2 3. Okay, so this is the matrix. I can display the matrix. Yes, you can see this matrix here. The matrix is displayed 2 1 1 minus 1. This is the coefficient matrix. Okay, now B matrix. Let us write down the B matrix. Okay, let us find B. Okay, remember that B matrix is a column matrix. So it means each and every row there is only single element. So we will write down the matrix like this. Suppose it is 2 3 10. So 2 semicolon 3 semicolon 10. Why? Because, sorry, because each row is having only single element. Okay, so let us also display the p matrix. Yes, this is the p matrix. Okay, now how can we solve this? Simply we can solve this matrix as x, okay, is equal to, there is a command lin solve. Okay, lin solve, that is linear equation solve, which is the lin solve. This is a command which is already available in MATLAB package. Okay, simply you will be writing a comma b, that's all. Okay, then we will just display this x, sorry, yes, you can see we are getting the solution now. This is this three at the solution. Okay, so simply we are displaying the x, that is very simple. It is lines of linear equation solving. For lin solve is a command which is available in the MATLAB package, MATLAB library. It is included. You can just, you need to write down the coefficient matrix first, then the b matrix, that is right hand side matrix. Okay, and after that x equal to lin solve. And what is x? X is a vector, that is a solution vector. The three, we can see, since it is 3 cross 3 matrix, so of course there will be three variables x1, x2 and x3, and these are the solution of x1, x2 and x3. Actually these 3 points x1, x2 and x3 together they represent one point here. Okay, because it is 3 cross 3 matrix. Okay, and easily you can solve this equation by using MATLAB. Okay, so next day I will also show you, that is, if how can you represent a system of linear equation in MATLAB. System of linear equation you can type here, and MATLAB can automatically detect what is the coefficient matrix and what is the p matrix. Okay, you don't need to write down the coefficient. You just need to put the system of linear equation in MATLAB. Okay, so this is the final that is slide today. Thank you for attending the lecture, for being with us, and you can also visit www.innovaworld.info for further information. Okay, and also you can visit the YouTube channel InnovaWorld, and all links of previous lectures you can get there in InnovaWorld channel, and also you can get the link in the description box of this YouTube. Thank you for being in touch. So the next lecture will be shared shortly. Okay, and in the next lecture I will also give you much more example of system of linear equations there, and also we will solve the different questions of competitive examinations.